We're recording. Excellent. All right, so first we're going to do apple trees. Looking at apple trees, what we're trying to learn here is we're trying to model systems with objects. When we talk about a system, we're talking about various different types of objects interacting with one another. We're also going to be using instance variables and accessing instance variables effectively and working with objects in Python. And so if we look at our releases, we can see release 0. Implement the apple tree and apple classes. Okay, we know how to do that. So I'm going to go ahead and fork this and then clone it. All right, now looking in here, I can see we have an apple file, which has an apple class defined for us. We have an apple tree class, which has a init and several methods defined for us. Then we have a spec file for both apple and apple tree. And we have a runner file. Let's take a look at that runner file to see, that'll give us some hints on exactly what this program wants us to do. So beginning of the runner file, we define a tree as a new apple tree. And then we start a while loop saying, okay, while tree.any apples equals false, so meaning while the tree doesn't have apples, we have to age the tree. Once the tree is done aging, we print, okay, how tall the apple tree is and at what age. And then we have another loop that says, while the tree is not dead, we have defined an array called apple basket. And we say while tree.any apples, meaning while it has apples, we add an apple to the apple basket using a method called tree.pickAnApple. Then we have a variable called average diameter that is equal to none, but it says right here that we'll have to change it so it's calculated average diameter of all the apples in the basket. And then at the end, we print the age of the tree, the height of the tree, how many apples we harvested, and what their average diameter was. Then we age the tree and do it all over again. And we keep on doing that until the tree is dead. Okay. That seems to make sense to me so far. We can also take a look at our spec files. So they've done it for us, which is very helpful. So we have things like, okay, what age tree should do. So when we run age tree, we should move the tree age up from 0 to 1. And we'll go over this in more detail pretty soon. But for now, let's just say, all right. We'll need to call tree.height and tree.age to get a tree's height or age specifically, respectively. And we can also add other attributes. Use the code in the runner file to guide us. Okay, so let's take a look at the apple tree class first. So we know it's going to have an age and a height. And if we look at the spec file, it looks like the original height equals that. So it doesn't tell us what the original height of an apple tree must be. And we don't really need to put too much thought into this. We don't really need to research how tall an apple tree typically is. So in this case, we know age is going to start out at 0. And let's say height starts at 1. And I need to make sure I say self dot here in order to make these instance variables. All right, so now now the apple tree class has an age and a height. If we look at apple.py, in this case, we know from our runner file that apples should have a diameter, right? So let's say self.diameter. And maybe since we've got to calculate the average, we would assume that every apple doesn't have the same diameter, so maybe we should randomize it. Oops. So in that case, we can import random and say self.diameter equals random.randint and make it between 3 and 7. Why not? So we have our apple tree has an age and a height, and our apples have a diameter. Are there any other things that we would expect an apple tree or an apple to have? It doesn't have to be things from the runner file. It can also be from just in general. Did anyone else add any other instance variables to their classes?
Yes, I did.
Mm-hmm. What'd you add?
Basically, I set it in a random number between like 3 and 5 when it was initialized for the apple tree, when it would actually start growing apples. Um, Also, I
Oh,
set another, random number between well, I set it for a height thing as a stopping point. So basically, I'd also keep track of whether it'd grow. So if grow is true, then do this other function as when it was as part of the age the tree function. Um, so yeah, there's a few different other variables I threw in.
mm-hmm. Yeah, so we could also add things like self dot max height if you wanted to give an absolute maximum to how high a tree could grow. So we wanted to set it to 20. We could do that, or a random number, either way. And for apple, we could do something like self dot varietal. I don't know if that's what you call it, but like an apple could be defined with, it could be a Honeycrisp apple, it could be a Golden Delicious, etc. So plenty of other things. I'm just going to leave it at this for now. But this challenge does encourage you to get a little bit more creative with things and make it work your own way. So what I'm going to do now is I'm going to start running first. First, I'm going to run the apple spec.py and see if there's any tests I need to pass there. Okay, so looks like apple spec.py. We have a diameter that's greater than 0, and that's all it really cares about. Awesome. So that works out pretty well. Let's try the apple tree runner, or spec. All right, so we got a few failures here. We got one pass, so that's a positive. So we can take a look up here. Age tree, and it says here 0 does not equal 1. Okay, well that gives us something here. Age tree, pass. And so one thing we could do if we wanted to be a little silly is like, okay, I just want these tests to pass. So I could say, okay, age tree, and I could just say self.age equals 1. That would make the test pass, right? Yep, we got 2 passes now. And I'm just showing you this as an example of why you want to make sure your testing suite is always robust and you test more than one case. Because right now, my age tree has passed the test because we changed the height from 0 to 1. But if I tested it again, it obviously wouldn't work. So just be careful for traps like that. What we want to do is say self.age plus equals 1. I'm going to clear the screen, run the test again. All right, what's wrong this time? Apple tree height. 1 does not equal 0. If we look at that test, so we're expecting, after we run the age tree function, we expect the height to be bigger. All right, so we can do that. So we could say self.height plus equals, it doesn't really say what we have to do, so let's make it age a random amount. Random.randint, and let's say it grows between 1 and 3 per year. Something like that. All right, we still have 2. Okay, that still failed. Let's see what happened this time. Okay, let's see. Age height. So we call original height equals appletree.height, and we're supposed to say that appletree height is greater than original height. Hmm. That's interesting. That should be great. We should be, all right, let's just plus equal 1. Just for now, see if that makes the test pass. Huh, interesting. So assert greater that appletree.height is greater than original height. Ah, wait a second. Ah, I missed something. We also had another test here that asserted that the original height should be 0. Okay, my mistake. So now if I clear this and run it again, the test should pass. There we go. All right, so now we have our any apples. So any apples says none is not true. So we take a look at any apples. So he says apple tree creates a new apple tree. There shouldn't be any apples at first. Then it ages the tree 10 years by using the itertools.repeat. And then there should be apples now. Okay, so let's just say return self.age is greater than, let's see, did they say that there's a minimum age that a tree has to have? Okay, it doesn't say that there's a minimum age, it just has to be after a while. So let's just say the minimum age is 5. All right, that's another test passed. All right, before I continue, does anyone, what questions do you have about A, what this problem is, and B, how I'm approaching it? Okay. All right, in that case, we now need to test self.isDead. So a tree should die at a certain age. Let's just make it a round number like 100. We can just say return if self.age is greater than 100. Or let's say greater than or equal to 100. 5 passes, 1 error. And lastly, we have test pick an apple. So right now it raises an exception, no apples on your tree. So let's give this some thought before we continue. We do self.pick an apple is, it says right here, self.assert equal type appletree.pick an apple should return something of type apple. So this is where our two classes actually have to interact with one another, right? So if I want my apple tree to actually interact with my apple, what do I need to do first? At the moment, does my apple tree class have any way of actually accessing the apple class at all?
In an import statement?
Yep. So I could do something like from apple import apple. That imports the apple class into my apple tree. And so picking an apple means we should be able to say, all right, we need to create a new apple object. Now, this is where I know we talked a little bit about this yesterday, and it's also in your reading. We need to talk a little bit about the law of Demeter. And does anyone want to give a crack at defining the law of Demeter?
Some parts of your program, different classes should know as little as possible about the other classes.
Exactly. So essentially, looking at these two examples, the apple tree class and the apple class don't need to know that much about one another in order to work. So at the moment, does the apple tree class actually need to know what the diameter of an apple is?
No, the apple tree does not.
The apple tree doesn't know, the apple tree doesn't care. It's not essential to the functioning of the apple tree class. And similarly, the apple class doesn't need to know about any of these methods. We don't need, if we have to say something like, okay, an apple needs to find out what apple tree it belongs to and then run the apple tree's age tree method, that's exposing too much. That means our apple class is now very, very dependent on the apple tree class. And right here, all we need to do is be able to instantiate a new apple. So you can say apple equals apple. And then we could say something like, all right, we know that we should be able to say if any apples return apple. Then we can say else we can raise the exception of no apples on your tree. Oh, all right, I'm getting my linter is picking up something wrong there. What's going on there? Why isn't it saying that any apples is defined?
You need to say it's an instance variable, self.any,
Yep.
or excuse me, method.
Yep, it's an instance method, which means I need to say self.anyApples. Clear this out, run my tests. All right, we passed all the tests. Does that mean we're done? No, because passing the tests, I've already demonstrated that these tests are not super comprehensive. So we may need to take a look at our apple tree runner and see if that works out the way we want it to. So I'm going to clear that out. Oops. Okay, well, it seems to be hung up on something, so I think we've got a problem. All right, so let's take a look. So if we created an apple tree, and we aged the tree, and said my apple tree is producing apples at tree age 6 and tall. And then looks like so the problem must have happened somewhere around here. So we had our wild tree.isDead, apple basket, wild tree.anyApples, apple basket.append. Ah, okay, I think I've seen where the problem is here. Does anyone else see it? Is there anything that actually breaks me out of this while loop?
Should be when you run out of apples, right?
Yeah, but if I look at my anyApples function, it just says you can have apples if the age is greater than 5, and the age is always greater than 5. So in this case, we actually need to model, okay, there's only a limited number of apples on an apple tree. So in that case, we need to figure out, all right, how do we keep track of how many apples are on our tree? And there's a few things we could do for this, right? So we could do something like, we could create an instance variable perhaps, and say self.apples equals 0. So this just is an instance variable that keeps track of how many apples are on the tree. And in this case, all right, if we want this number to go up, we already said, all right, a tree needs to be older than 5 years old in order to have apples. So maybe we need to say if self.age is greater than 5, then we could say self.apples plus equals, and then we can use random.randint and say it gets between 10 and 20 apples. And in this case, anyApples we're not saying is the age greater than 5. What we want to say is, are there apples on the tree? So in this case, we may do something like return self.apples is greater than 0. In order for that number to go down, instead of we're not just going to return the apple, we also need the self.apples to decrease, right? be self.apples minus equals 1. Let's try it again. Oh, I realized I used green to run this runner file instead of a use the runner file instead of that. So if we look at our report, though, it's a very long report. Maybe I'll make the age it dies a little smaller next time. So the tree keeps growing. 14 apples, 20 apples, 13 apples. We haven't calculated the average diameter yet. So I'm just going to change the is dead thing to make it maximum age of, let's make it 25 this time, just so it's easier to actually read. There we go. All right. So this looks like it works pretty well so far, except we don't have the average diameter yet, right? Let's take a look at that. So right now, average diameter equals none. We need to make this so it is the calculated average diameter of all the apples in the basket. All right, so in this case, this is less a object-oriented program. This is more of a math problem, right? How do we calculate the average of a number of apples in a basket?
Add the diameters together and divide it by how many apples are in the basket.
Yep. So if we wanted to get the sum of all of the diameters of the apples, so we might need to do something like total diameters. Actually, maybe we want to do something like this. Oh, wait, so it'll be for apple in apple basket. Total diameters plus equals apple dot diameter. And then we could say average diameter equals total diameters divided by LEN of apple basket. That look good? Let's try it out. All right, so if we look at this, we've got some long repeating decimals, but there's no problem. That isn't really a problem per se. All right. What questions do you have about apple trees so far? All right, I just want to do one more thing. I want to kind of show there's like another approach we could take to this. And I'm not saying one approach is better than the other. I just want to show that there's multiple ways of tackling this problem. So what if instead of self.apples being an integer that keeps track of how many apples we have, we made self.apples an array? And then whenever we added apples, instead of just increasing that number, we increased that number by a random number. We added a random number of apples to that. This would be like for I in range random.randint 10 to 20 self.apples.append an apple object. So in this case, we're kind of modeling this a little more literally. We're actually literally having our apple tree have apple objects. And in this case, since any apples would return len of self.apples is greater than 0. And instead of returning a new apple object whenever we pick an apple, we would instead say, just get rid of all this and just return self.apples.pop, which just removes one from the list.
That's how I did it.
And if we run it again, it still works just fine. And the reason that I'm taking this approach is because it lets us do things like say, all right, I'm just going to put it right here. Print tree.apples. It allows us to see all of the apples on the tree before we pick them. And right now, all we can see is that they are apple objects, and they give us the IDs. So it's actually very instructive to read, but we can do that. And if a tree already has a number of well, I guess in this case it doesn't make sense. I was about to say that we could have a tree calculate the average diameter of its apples, but in this case we're calculating the average diameter of apples that have already been picked. So that doesn't make sense. But any questions about that particular approach?
One thing that may or may not be useful, because we were running the runner mile, and I think at one point when I was trying to determine about the apples, and pretty much went down this approach here with the apples as a list, and I actually attached an apple object, assuming that nobody picked all the previous apples for the previous year. So when it comes to the next age cycle, the first thing I did was cleared out, basically reset the self.apples equals a blank list at the beginning of the age tree. So if I had 100 apples left over, nobody picked them, okay, they all went to waste, and just reset it. So
that's a good point.
That way you don't accidentally by year 99 or 100 have like 10,000 apples stored up on your list.
That's a good point. Yeah, that's we can definitely do that as well. That's good thinking. And let's see here. Is there? Did anyone else have any other approaches to this problem that they'd like to share? Because again, this is a very open-ended problem, and I like hearing people's solutions about it. Get in the chat.
The only thing I accounted for is if you ever have a year where you don't have any apples at all. So I put a 0 for my number because it's possible that you don't. There's one year where you wipe everything out.
Yep. All right, and Julian just shared a mathematical approach using the statistics module. So there's a statistics module that gives you access to lots of different more math stuff, including calculating the mean, and also using the map function as well, which we'll get to another day. So that's definitely another approach that kind of is a little bit cleaner than what we did right here. It gives you the entire thing in just one line. Yeah. So otherwise, that is apple trees. All right. So let's take a 5-minute break, be back here at 9:07, and then we'll get started on ice cream.